This next one is another video. The beginning's kind of silly, but it does kind of make a point about um, the findings in this experiment, and then the graphics kind of show you how it works. It's Rutherford's gold foil experiment. So I want you to watch this, and then I want you to take a moment and write an outline for the experiment. So like, how was it conducted? What did what were the results, and then the key findings would be like the takeaways from the experiment. Uh, Here we go.
It was quite the most incredible event that has ever happened to me in my life. It was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you. Quote Ernest Rutherford, recalling the discovery of the nucleus. So this is a diagram of Rutherford's experiment. Alpha particles are very, very tiny, positive, and dense. They're sprayed against this lead sheet, and the hole allows a thin beam of them to be shot at a piece of gold foil. Surrounding the gold foil is some zinc sulfide, which will flash green when an alpha particle hits it. Now, if you've noticed, not all of the particles went straight through. Some went off at an angle, and very, very few actually bounced back. So what did Rutherford conclude from these experiments? Well, since most of the alpha particles pass straight through, an atom must be mostly empty space. The deflections must have been caused by something positive repelling the positive alpha particles. And the bouncing back must have been due to head-on approaches of the positive alpha particles and something positive. And since so very few of them did deflect or bounce back, whatever this positive thing is must be very, very small compared to the size of the atom. He discovered the nucleus.
All right. So, I know that intro is kind of silly. Um, I want you to now outline the experiment. So, what did Rutherford do? And then what were the discoveries or the conclusions that Rutherford made? So take a second, write down an outline, and then the findings, and then we'll talk about it. Okay, so the experiment itself, right? Alpha particles, which are helium nuclei, were fired at a thin sheet of gold foil, and most of these alpha particles passed straight through, but a small number were deflected and some were reflected, essentially straight back, which is where that silly quote comes from at the beginning of that video, which is from Rutherford, because they're firing the alpha particles super fast and some of them still bounced back, right? Rutherford inferred from this that most of the atom is empty space, so the electrons are diffused in space around the nucleus, right? They are not right next to the nucleus, they are far away. And a small dense area of positive charge is found in the middle of the atom, and that's what got named the nucleus. So these are the findings, the inferences, and conclusions that Rutherford made based on the data that was collected. This is a super important experiment because essentially it led to the discovery of the nucleus, right? Which is a very important piece of chemistry now. So I want you to think about this in terms of the nature of science now. And I want to talk about observation and inference. So, in relation to Rutherford's experiment, what do the terms observation and inference mean? What's the difference between those in the context of this experiment, right? And then I'd like you to also answer which is likely to be more objective and which has an element of subjectivity. Um, and then number 3, can we ever be certain of a particular atomic theory? So those are your 3 questions. Take a moment. Um, Again, there's not like a perfect right answer to these. Just do your best. Do what you think. These questions are to make you think about science and observations and inferences and certainty. So take a second, pause the video, write down your answers, and then I'll talk about what I think. Okay, so for this experiment, if we're thinking about observation, observation is when we use our senses to record data about a phenomenon. Sometimes we also use instruments. So in this case, they observed flashes on a detector screen using our eyes. Inference is the use of the evidence and data we collect and reasoning to reach a conclusion from our observation. So inference uses our observations. In this case, Rutherford inferred that the atom is mostly empty space and has a small positive nucleus at the center. Observations are more likely to be objective, right? We are taking data, we are using our senses to gather information, and that means that inferences are going to be more subjective, right? Because it requires interpretation and reasoning, and so there's multiple steps there in our own rationale and logic, which introduces subjectivity. Another question we could ask is, are observations completely objective? Do they have a level of subjectivity? I would say they do, but we could, you could argue about that if we wanted. Number 3, can we ever be certain of a particular atomic theory? So I would say, although some of these theories may be very well supported with evidence, we should be really careful of saying we're certain of something because there's always an element of interpretation, right? And history also shows that when we are certain of something, we often are proved wrong or it's slightly different than we thought, right? There's been many widely accepted theories like the Earth being the center of the universe or the solar system, which turned out to be false. So I think a good scientist always has some skepticism, even with the best established theories. Okay, so let's talk about nuclear symbols for atoms. So right here we have helium-4, and we have these 2 numbers here next to helium's atomic symbol. And we need to know how to read a symbol like this. So obviously the He means helium. You can look at the periodic table for that. But these numbers also have meaning. And if I throw up a picture of what this looks like, we could probably figure this out, right? So we have a helium atom. In its center, we have 2 protons and 2 neutrons. On the outside, we have 2 electrons. So this 2 is referring to the 2 protons because the amount of protons defines what element we have. So if we have 2 protons, that is helium, right? No matter how many neutrons or electrons we have. This 4 is referring to the mass number. So we're basically adding our protons and our neutrons up, right? So we have 2 protons plus 2 neutrons gives us 4 total things in the nucleus. And then we'll get to the electrons in a moment. But here's kind of what I was saying. So bottom left is the atomic number, the proton number. Top left is the mass number, which is the sum of protons and neutrons. If we already know that this atom has 2 protons, right? Helium always has 2. Then it must also have 2 neutrons to equal 4. And an atom is always neutral, so the number of electrons will be equal to protons. And we'll get into this distinction with this in a second. But if we're talking about atoms, that means the protons equal the electrons, so 2 to 2 in this case. So, quick check. Write the nuclear notation, so that notation we were just looking at for these atoms. The first one is this image. You can see things are labeled here. Then a fluorine atom with 10 neutrons. If you're not sure what fluorine is or how many protons it has, look on the periodic table in your data booklet. The number at the top is the number of protons. That's its atomic number, right? And then an atom with 15 protons and 16 neutrons. So again, look at your periodic table. Number 15 is the one that has 15 protons. So I'll give you a moment to try and figure these out, and then I'll talk about the answers. So the image over here, right? We have 3 protons, 4 neutrons, and 3 electrons. So that means it's going to be lithium, Li, the third element on the periodic table. It has 3 protons, so I put that on the bottom. And it has 7 total things in the nucleus, because we have 3 plus 4. So we put 7 for the mass number on top. A fluorine atom with 10 neutrons, we would write F for fluorine, right? That's our element. Fluorine is the 9th element on the periodic table, so we're going to write a 9. That's how many protons we have. And then we have 10 neutrons, so 10 plus 9 equals 19, so that's what the mass number will be. An atom with 15 protons and 16 neutrons would be a phosphorus atom, right? Phosphorus has 15 protons. You can find that on the periodic table. And then 15 plus 16 is 31, so that would be our mass number up top here.